Hello everyone, I'm Dr. Jinying from the University of Cambridge. Currently, I'm a research fellow. And sorry I couldn't join you in person because of visa reasons. Today I'm going to present you my small research about the evaluation of the effectiveness of the best practices in carbon reduction in the UK highway sector. So just for a little bit of background, UK National Highways has set out net zero targets in different aspects. So for corporate emissions, they need to reach net zero by 2030, maintenance construction emission net zero by 2040, and road user emission net zero by 2050. And that's very good. They have the plan, but like whether they can reach that, that's what we want to find out. And according to the project control framework, there are 7 stages, and that's how they also evaluate the carbon reduction strategies. And there are the key management activities. I'm not going to read them here. You can refer to the paper. And so the objective of this paper is, as I said, to find out what are the key carbon management strategies they are using, and what are the focuses for these strategies and the tactics, and how efficient are they, whether they can help them to reach the net zero targets. And so for the method, it's quite simple. So I accessed the National Highways Carbon Hub database, and they have the lesson learned reporting scheme, which provided a lot of, which recorded of like all the lessons learned from the projects in the last decades. So I got 1,000 entries, and then I try to use NLP to extract the data that I want. So I got over 250 entries with cost data, 78 with carbon data, and 46 with both. But then if I look into whether they are really aligned, I only find 18 entries that can be used to analyze the carbon cost reduction efficiency. And so quickly the results. So we can see in the carbon reduction strategies, there are 3 key strategies, includes avoid, reduce, and switch. Avoid means like try to not build anything, and reduce is build less, and switch is build smarter in different using different methods. So there are more projects using switch, and just a few that use the reduce. And so for the design, and most of them would like focusing on different aspects, including low carbon material, low carbon energy, and this kind of thing. So this is of all the projects that I have this data, right? The 65 projects. And so these are about the different areas that I focus on. So this is a construction project and program, and these are the specific methods that they use to reduce carbon. And these are the different PCF stages that they focus on. Also, we find out most of the projects will mention something called carbon quick wins, which across national highways is being widely used. They include the warm mix asphalt instead of hot mixed asphalt that reduce the carbon, and also eliminating the equipment idling, which would reduce the use of the fuel, right? And also specifying alternative mix for auxiliary concrete, which like as long as they meet the non-structure like requirements, they can be like lower carbon, and the sourcing renewable energy, which is obvious. So to be like a carbon quick win, they have set out 5 criteria, includes a high impact. So like all these strategies have a big impact, and they need to reduce carbon, or at least not increase carbon, and of course reduce carbon, and then no departure from standards, which means they should still be complying with standards, and they have at least level 4 of the maturity level, and they can be applicable with little or no limitations to any projects. And also, then as I said, like I find out 18 cases that I can use to evaluate the cost effectiveness. And you can see that among them, so 11 projects use the switch as a strategy, and the other 6 use the reduce, and only 1 use the avoid. And so most of them would switch to low carbon material or low carbon energy, and they focus mostly on PCF stage 3, 5, and 6, which are preliminary design, pre-construction, and construction. And the carbon savings, this is the numbers that I find. And though I also did find out the cost saving of the carbon reduction strategies, and calculated the marginal abatement cost, which is an indicator to evaluate the effectiveness of carbon reduction, of cost effectiveness. So you can see that most of the numbers are negative, which means they save the cost, and only one project is not. And I will talk about that project a bit more. And also, so you can see the mark varies significantly among different projects, and but most of them are like bigger, like the absolute value is more than like 70 pound per ton, which is the carbon price for 2030 that I found in a report. And so for the case 5, it is the only one which is like may extra cost to reduce the carbon, and these are the like opportunities they identified. Most of them are focused on the construction stages, some on operation, and which includes different types of, like maybe some are material, some are different using different material, different energy, stuff like that. And some of them they would have the potential carbon reduction numbers. They can like estimate the potential, but some they don't know, so they might not record like how much they could be saved. And also the extra cost, for some of them they would know that that would require extra cost maybe. So a lot of this require extra cost, which then means that's why the overall actually need more investment than like saving to save the carbon. And for to summary, I can find that the primary focus area for carbon management is project and program management at the construction stage, and the most obvious strategies they use are to use low carbon material, low carbon energy, and so there's also, but from like the data sample that we got, like only 18 projects out over 1,000 entries have the both cost and carbon data that are aligned, which means there's a big significant lack of comprehensive data, and it significantly limits the ability to assess the cost effectiveness of various measures. And because we know that the industry really cares about the cost of this, and nobody's going to really pay for the reduction of the cost of the carbon. So we need to have strategies that is saving the carbon and at the same time reduce the cost, at least not increase the cost. So it's very significant for us to understand the numbers to know which strategies work. And but also one thing to mention is I kind of find it difficult to ensure the data trustworthiness of this carbon data and the cost data. So there's this that I find also the same strategy may have different cost effectiveness, and I don't have enough data like the granular data to look into it. So recommendations quickly. We need to develop standardized methods to measure the carbon and the cost at the same time. So they need to be aligned, they need to be measured simultaneously, and only by doing this, we can then identify the cost effectiveness and we can know which strategies would work. And that is very important for our carbon reduction policies and for us to reach net zero targets. And finally, I would like to thank the European Commission's Horizon 2020 project, which funded my fellowship at Cambridge. And I'm going to join NUS as an assistant professor, and I will welcome you next year in Singapore for the ISARC conference. Thank you very much.